It has a particular kind of odor, maybe sweet. You might not find that objectionable at certain concentrations, but at higher concentrations, you will find it objectionable. And in fact, it'll get to the point where you will say, I won't drink this water. I'm going to call whether it's a bottled water company or a municipal water company and say, this isn't right, something's really wrong, you have to do something. And that's the OOC, the odor objection concentration. So those are what I'm going to be talking about. These are what we determined with the expert panel. We had selection criteria for our panelists. We wanted to, first of all, have trained panelists. We wanted them in a specific age range, obviously older than 18. We wanted to have adults, even young adults, but no older than 65. After 65, a person's ability to smell or taste starts to decrease, and it becomes fairly rapid after the age of 70, for example. So we wanted to have panelists in this range. We wanted to try to get a balance of men and women on the panel. As you'll see in a minute, we weren't that successful in doing that, but we weren't trying to represent the population of Charleston when we were doing this. We were looking for experts. And so we took what we got, which is about 2/3, 1/3 women and men. Pregnant women could not participate. We weren't necessarily worried about any toxicity problems, but any woman who has gone through the wonderful experience of having a child will tell you that she becomes acutely and intensely aware of odors during pregnancy. And so that really produces a set of results, and this has been documented in the literature, which is unusual and not part of what we were looking for. We're not looking for the absolute most sensitive, worst case. We're looking for a more reasonable, not reasonable, but a more trained panelist type of response. Non-smokers for obvious reasons, no asthma or sinus problems, and anybody with a cold or flu couldn't participate. I had a really bad head cold during this. I was going to be part of the expert panel, but I could not participate because I simply couldn't smell anything. We did have a 67-33 split for women and men, and the age distribution was not surprising because we had over 50% in the 18 to 33 category. We were using a lot of students from UCLA, the University of California in Los Angeles, who have been trained by Dr. Mel Suffolk in the flavor profile analysis and do this on a number of samples and in a number of studies. So that's why we have a preponderance of young people. I'll show you some data when we get to the consumer panel study that for our work, age didn't make much of a difference. Some studies have shown that people at younger ages can smell better, but that wasn't the case here. We had panel sessions. We had 2 panel sessions. One was at the offices in Los Angeles of a consulting firm, Hazen & Sawyer, who have experts in odor that do this as a matter of course for a variety of samples. And then we had a group of students at UCLA in a special odor and taste room do the determination, and a total of panelists of 9. This is one of the most important slides in the presentation. We spent a lot of time assessing crude MCHM. One of the things that the West Virginia Army National Guard was incredibly helpful about was they went to a tank in the POCA blending facility and sampled that 100 milliliters of product that came from tank 396 on the property of Freedom Industries, the tank that spilled into Elk River. This is the material that went into the river, it went through the treatment plant, and it ended up in your homes and in the distribution system. This is actually PPH. This is a sample of just the pure MCHM, which you can go out to any chemical store and buy. The pure MCHM and the crude MCHM are different. They have different odors, and they react differently in water, and people smell them differently because there are minor components in the crude MCHM that have odor characteristics that make the licorice odor of MCHM much more intense. So it was crucial that we use the crude MCHM throughout all of this testing. There's tank 396. We went and visited it yesterday. But we had to use a type of water for this testing that was a type of water that was not going to interfere with the testing and would be a relatively easy water to drink, no off flavors of its own. I'm going to knock this thing off. We chose Arrowhead spring water. It's a spring water used in Southern California where we were doing a lot of the work. And so it's a very odor-free water and easy to get a hold of in Southern California at least. We did end up shipping some to Lancaster, Pennsylvania where the laboratory was, but that's what we used. And we spiked the crude MCHM into that Arrowhead water for presentation to the panelists. There are many ways of determining odor thresholds. One of the most popular and most widely used is called ASTM E67904, 04 being 2004 when it was developed, and then 2011 when it was reaffirmed. This is a methodology that is based on presenting 3 samples to a consumer panelist or an expert panelist and asking them, the first question is to pick the different cup. Pick the cup that has a different odor in it. 2 of the cups have blank water, and 1 of the cups has the spiked amount of crude NCHM. And as you will see in the numbers, some of these concentrations were very, very low. So sometimes panelists can detect that difference, and other times they can't, but they must make a choice. This is called a forced choice triangle ascending series method, and it's used throughout the food and beverage industry. Once they choose the different cup and score it on their sheet, we then ask them to do 3 other things. First of all, describe the odor characteristics of that different cup. Now, before we started all this with each panelist, we took them into another room, we gave them a little bit of a whiff of crude MCHM and asked them to describe what that was in their own terms. Then, once they got the different cup in their triangle, they described what that odor was, and we tried to match up. We tried to match up, I must be part Italian or something, we tried to match up the odor that they described of the different cup with the reference odor that they gave us at the beginning of the panel study. So after they described the odor characteristics, they were asked to express their degree of liking. How much did you like the sample of water in that different cup? Using a standard scale, which I think I have, yes, I do have a slide of that. And then finally, to get at this objection level, we asked the panelists that if this odor in the cup, if you detected it, would you object? Would you pick up the telephone and complain to a bottled water company or a municipal water company if it was in your drinking water? These are the kind of data that you get from this kind of analysis. Now, I know it's very difficult to see this. I urge you, if you're interested in the details of this, to go online. We posted all of these results online with the report about the expert panel results. But I'm just going to show you generally how we did the calculation. We had 9 panelists. We had 8 concentrations ranging from 0.16 parts per billion to 100 parts per billion. So a very wide range of concentrations of crude NCHM. The panelists then tried to pick the different cup, and for the expert panelists, again, not surprisingly, everybody, just about everybody, 7 out of the 9 panelists were able to get all of the 8 cups correct. They were able to choose that different cup every time. 2 of them did not, and this is the example that I'm going to use on how you do the calculation. Once you have a miss, which is the 0, followed by the plus signs all the way up to the maximum concentration, that is your individual panelist odor threshold concentration, OTC. And if I show you this, what you do is you calculate the geometric mean of these two numbers, which means that you multiply them together and take the square root for two numbers. And that results in a value of 1.6 parts per billion for that individual panelist. You then take all of the individual panelists' odor thresholds and you determine the geometric mean of them. And that results in a value for this particular panel of 0.15 parts per billion. Now, what we would like to have is for the panelists to miss a few in the beginning and have most of the results grouped here in the middle. But since this was such a sensitive panel and we didn't actually challenge them with a low enough concentration, all we can say here is that the geometric mean is less than 0.15 parts per billion for this panel, for this expert panel. These are all the data for the odor recognition, and I'm going to bring up one example, which is here for this panelist, and show you that they called it a strong solvent, but that's not what they called it when we asked them in the beginning. This person specified licorice pine, and it wasn't until they used the word licorice, and then licorice subsequently after that, that we determined that they in fact knew what they were talking about, and that equaled that. And it was the geometric mean of those two concentrations that we then calculated for that individual's odor recognition concentration. And then again, the geometric mean of all the individuals, and we came up with a 2.2 parts per billion for the odor recognition concentration for this expert panel. The degree of liking, I mentioned that a scale was used. This is a scale that's in a book called Standard Methods for the Analysis of Water and Wastewater, which is the Bible that we use in the field of drinking water and wastewater treatment. And it's a degree of liking that is pretty descriptive if you look at it. It runs all the way from, I'm really happy with this water and it's terrific and I want to drink it and it's great, to, at number 1, to number 9, which is I don't want to be within 15 miles of this water. This stuff is really nasty. So you have everything in between. We determined after looking at a bunch of data that the break point between acceptance and rejection, or the acceptance and objection and complaining, would be when you get to the level of 6, which says, I don't think I could accept this water as my everyday drinking water. And again, we had the 9 panelists, we had them score it, and you can see that, well, maybe you can't, it's a little small, but once you get up to 6, and it's consistently above 6, after that, you then are able to determine the individual odor objection concentration, and then you do a geometric mean of those individual results. And for this expert panel, using degree of liking, the geometric mean, the odor objection concentration was 4 parts per billion. Remember, we asked them if they would complain or object, and it's a yes-no kind of answer. Once they got to a point where they were consistently answering yes, that they would complain, we did the same calculation of the geometric mean of those two numbers, came up with the individual values, and then did a geometric mean of all of the individual values. In this case, resulting again in 4.0 parts per billion for the odor objection concentration. So what does this mean? Well, a methodology was developed and it really worked very well. And the reason why it worked well is because, first of all, the people who are running this, including myself, are very experienced at doing this. We've done this with other chemicals, but it's a terrific method and it does give you good results. We use it for odor threshold and odor recognition, which are pretty well accepted in the literature. But part of this work was adapting this methodology to determining when the concentration is reached of objection. So we're reporting that for crude NCHM for the objection concentration. We did a spiking methodology that worked very well and gave us, especially with the sensitive analytical technique that Eurofins is going to talk about, we got good recoveries and good confidence that the concentrations we were presenting to the panelists were exactly what we said they were, and that was confirmed by analysis. Here's the summary of the results, which I've already told you about. The odor threshold less than 0.15, recognition 2.2, objection, we have two measures. In this case, they're very close at 4 parts per billion. I calculated how much greater these other thresholds were than the odor threshold concentration, and you can see that they're quite a bit higher. In the case of determining how a distribution system or people drinking water from a distribution system react, these numbers are actually more helpful in understanding how people react, because they're recognizing it and they're objecting to it, as opposed to just determining the difference between certain cups. But all of this information together tells us very, very important data for the citizens of Charleston and environments. We were able to estimate the odor threshold concentrations, especially in the realm of parts per trillion, which is a very, very small concentration, and certainly determined that the expert human nose was able to detect this compound in a far lower concentration than any analytical method available today. And I think